Hi, this laptop is a HP Envy 17-inch. Well, we've got a model number there, 17-J007TX, as far as I can tell. And come to me with the complaint that it was destroying the charging supplies. Power supplies, and quickly proved that wasn't the case. When you plug it in, yeah, there's no power, and if you tried that supply immediately after without removing the mains for a bit on a different laptop, then yeah, it would not charge that laptop either. So it looked like it was destroying the chargers, but what is actually happening is some kind of overload situation caused the supply to shut down, and the only way to recover from that is to pull the mains plug out and wait for a minute or so for it to discharge inside and come right. So now we have to figure out what could possibly be causing the overload. So we're going to start with the input, of course. We've got our DC jack in the corner, and the cable snakes its way over to the board. And what we'll do, this has, I think, some kind of data line in there as well. There's red, black, white, brown and yellow by the look of it. So there's probably some smarts going on there. But normally there's, if you check the outside shield of the plug, which is, so there's our charger plug, the outer shield, and the little pin in the middle will give you your 18 volts or 19 volts, whatever it's rated to. Usually 19, actually 19 and a half according to the sticker. And then there's another around the inside wall of this cylinder. There's another connection. I'm not too sure about the rest of those wires, but what do you reckon the best thing to do would be? We know that it kills it if we plug it in. We presume there's a fault on the board, so how about we go ahead and disconnect the plug from the board, take the socket off the board. It's a retaining clip, just have to bend that out the way. That'll release our wires, and we've got the Wi-Fi antenna cables also sharing the same path. Just get them out of the way, and then we'll unplug our plug there to the DC jack. So if we plug it in now and it does the same thing, well, that's pretty much solved. There's a problem with the input DC input jack. So just to show you, we'll have our connector on the barrel, and I'm going to probe down the center without joining the pin to the sidewall. We don't want to screw anything else up, but till I feel the pin. There we go, 19.5 volts. Whoop, there we go. So we know that's working. Now all we need to do, plug it in. Now I'm going to measure. We'll be going up here. We've got black and red, should have 18 volts on it still. Not too worried about the signaling lines, because we know that this does provide 18 volts without having the motherboard to tell it to turn on, for example. So I'll tell you what colors we're probing. You can see with me if we get a result. And I get black and red. Pop that on there and not a problem. So it's definitely a motherboard fault. So the next thing we want to do is look for perhaps we have a low resistance on the input, and we've got the top there, that pin at the top, the one directly underneath it, and then the second one down at the bottom underneath those. That's where our red wires come into, and the black wires we've got our third one in and our one directly below that for our ground. And it looks like one further back as well, so I'll be probing the third one down and the top one because they're all joined together anyway, so we don't need to probe every single one. So I'm probing black, which is our third one down, and red, which would be our top one, and we'll see what we got. That looks fine. 150,000 ohms is not going to overload the charger on this. Okay, so here we are looking at the DC in section, as labelled DC in case you didn't know where you were. And what do we got? Oh, we got something marked speaker. Interesting. Nothing really burnt looking or obviously bad, but what we do need to be looking for is some sort of short to ground. Here's our battery connector. But yeah, some kind of short to ground. So what do we have that goes from, here's our pin, our red in. Now we've got to see where that goes to. Pretty sure that goes to these two input chokes here. So if we just do a continuity test to here we go. You can just sort of see it snaking around up under there. Just snaking around up here through these into this MOSFET. So we did not have a short to ground on this side of the MOSFET, so we're connecting ground, which is third pin down, and we can check that on one of the screw terminals. That's ground, there we go, and we're clean straight off the input to this MOSFET. What about the other side of the MOSFET? If we probe there, no, so we don't have a low resistance there. That goes through this MOSFET, and then that MOSFET there. Those two actually may be switching across this coil to create a rail of some sort, possibly. So if we check our coil is intact, does that go through to, no, it doesn't go through. Oh, there we go. So this is on the coil, but this one is not. Oh yeah, of course. But if that's switching high side then low side, surely one of those would measure through to the high side, to the coil. That's interesting. Yeah. So we've definitely got our low side. Let me just quickly look at the other side of the board. We can see that our positive comes through this FET and goes through this resistor and ends up here. These vias go through to the other side of the board, which are coming out here, and they go through. There's a little jumper here, but then here is another pair of MOSFETs which go to the other side of the coil. So that's how that's connected. And I wonder if any of those go to ground. So that coil goes to ground, So that's going to ground that side. That one's not. Oh, that probably goes through to the other side here. Okay. So if we check our gate drain, gate source, there, maybe our positive feed will affect it. I'll just check this one, gate drain, gate source, maybe it's a P channel, that one. I'm getting nothing off those. 0.1, half. No, it's normal to get nothing, depending on the circuit connection. Gate drain, gate source don't always give a reading. But I'm definitely, if I go across here, I'm getting a short to my gate drain. I have a short across there, and so what that's going to do is effectively turn this on all the time. If we get our positive feed coming in through this MOSFET and then into our drain, and the gate is connected to the drain, so it's going to see that and turn this on full time, which is going to provide power through here full time, which is not ideal because it does need to be turned off and on in sync with the ground side switching, so that it maintains a appropriate current through this coil. But I think at the moment, because that's not happening, it's causing I'm thinking that this coil is related to our charging circuit. This is our charging coil, comes down to the battery connector, and I would say that that is providing battery charging through a charge controller, which is switching those FETs to suit, because you can't just jam 18 volts onto a battery. When it is not plugged in and it's using the battery, you'll find, I think, that the power will come along here and through this FET back into the system. Now, is this using our body diode? It is. There's a half volt drop across here, so it's quite normal that this will switch on the battery power to power the laptop, and when it's plugged in and charging, you'll find this one gets turned off, so that it's the charging coil feeding the battery. It might even go through here. I wonder if they're using that for current sense. I think they are. There's two little holes there, little vias. Let's just pop in a bit closer for you. Yeah, they'll be current shunts. So we've got two little, one going to each of those contacts there, and the same over here. There's two. There'll be one for each contact, and these will be sensing the current flow through those. So for charge current or run current, because as I said, charger voltage comes in and it goes through this FET, through here and out to the system, or battery power comes in through this FET and out to the system. So this is going to be our main current shunt for the running of the system. Now, just a quick check then. Do we have a short to ground on the system side, or on that current shunt there? So if we go from ground to current shunt, and I've got a resistance of, why didn't I check that before? 0 ohms. There's 0 ohms to ground on the end of this current shunt. Well, it wanders off into the system, and there is a lot of places that it goes to. So I think we're going to have to use heat. We're going to have to pop some power onto the board and find out what gets warm, and hopefully it'll rear its ugly head, because it really does go all over the place to all the other switching regulators, and it really could be any cause, any tiny little surface mount capacitor or what have you. So we'll get rid of the memory and find an appropriate, I think we'll stick on the current shunt, we'll pop a wire on there and a wire on a ground point, and start with that and see. It shouldn't take long to find it. Okay, I've got my wire attached. We've got our positive coming down to our current shunt and our ground on ground, and already it's drawing 300 milliamps, and this power supply is set to 0 volts. So yeah, it's a very solid short to ground. So it's going to be interesting to see. Like, I've only got a 3 amp supply in this box, so I don't know. I don't think I'm going to really be able to get much voltage, much power through this. It could be tricky, but here goes. So as it sits, I have a little bit of warmth here, probably from soldering, but nothing jumping out at me. I just feel around underneath. At 1.6 volts we have 3.2 amps. That's completely maxed out, and yeah, completely maxed out there like that, which that's only making just under 2 watts. What's that? 1.5 of 3 is not a lot. 4.5 watts, I should say. So we're looking for very minor temperature increase. But, oh, yep, I found it. I don't like where that burnt me, and I don't like which part of the board burnt me, but that feels like CPU territory. We could have a bad CPU rail. Alright, I'm going to flood the area with alcohol and tap on the power, and we'll see what we get. But it felt like around here, could even be that. There's a funny mark on the corner there. Oh, you can't even see that. That capacitor there, there's a funny mark on the corner, so it could be that. It could be these regulators along the bottom. But let's start with those. Get them nice and wet. Yeah, I think I found our culprit. Let me zoom in a bit, make sure you can see that. So what I'm looking at is these two capacitors here. The one on the right dries out extremely fast when I apply the power to it. 3, 2, 1. Look at that. Look at that. It's just wet to the top of that again. Make sure we can see that. There we go. Yeah. See how that dries out extremely fast on the top there, and this one doesn't. So pretty sure the rest of them are all right. Let's just watch the other ones as well. Yep, I'm going to say that's our baby. That's our money shot. So now we need to take that one off, and it should go away. Right, let's go in for the kill. I have ordered a better light ring for my microscope, so that should be here soon. It would give a much brighter image. Has so many more LEDs, like almost three times more. Okay, let's check this dude. Listen for the beep. Is he a short? Yes, he is. How about that? And probing between ground and the end of our current shunt again, and we have silence. Let's just get a resistance reading there. We have many K ohms, many thousands of ohms. Now, question is, what do I replace it with? We got no idea what that is. I'm picking it's a like a 10 microfarad, I don't know, 16 volt. CPU is not going to run on 16 volts. So I just removed its partner, and I'm going to stick the meter across it while I knock everything out and ensure we have a good connection so we get a good result. And there's still a bit of warmth to it, but it's come up at 11 microfarad, so I'm happy to say that it's coming down as it cools down. I'm going to say that's a 10 microfarad cap. This won't give me a reading in circuit, so I'm going to see if I can find one on an old board. Well, I have managed to find one. I really should order stocks of these, shouldn't I? And a quick last check, make sure that everything's good again. Ground to our rail, and we've got 500 plus 1000 ohms, so that was the problem. Get these wires off, we'll plug it back in, and we'll see if the thing turns on. Okay guys, the moment of truth. Plugging it in and pushing the power button. What do we got? Well, the fan spins. I heard it. I got no image. Stand by. One must have great memory in order to achieve greatness. Plugging in again. Power. Come on, really? Third time's a charm. Ha ha! There you have it. Oh well, what more can I say? That was a simple fix. Another example of how to use heat to try and find your fault. So many times the little ceramic capacitors just go dead short. Well, thanks for watching once again. Hope you're all keeping well, and with any luck I'll have another one for you soon. Catch you later.